Let us solve the exercise number 5 in the part B of data structure lab. In this exercise, we are supposed to implement a queue using linked list. So let us first understand what is a queue. And we are all familiar. Queue is nothing but data structure wherein you try to insert the element at the end of the list, and you try to remove the element from the front of the list. So there will be two pointers that will point to the front and rear of the queue. Whenever we want to add a new item to the list, what we do is we go to the rear pointer, we add the new item, and then we move the rear pointer to the next one, and naturally the end of the list will be grounded. Whenever we want to remove an item, we move the pointer to the other side, to the next item, and we free the element from the queue or from the memory. In any case, we are following the same data structure, and that is a data structure that contains one field for the data, and the other field indicates the next pointer. So let us go to the code block here, and let us try to create a new program here. So I'm going to go here to the new, and I'm going to click on the new file. I will select a C++ as my code, and then let me go next and select C, and let me go next and try to save it at a proper location. Let me say that queue with the linked list. I'm just giving a name QL. You can give the full name, but advisable not to give spaces in between the names. So let's go ahead and let's create the program. First of all, I'm going to include the stdio.h because I want some input-output operation to be performed. And let's first create this data structure, which contains two fields. The first field contains the data. I generally assume that this is going to be an integer number, and there will be a pointer to the next structure. So that this is how we are going to do it. So let's start with the structure, and I'm going to call it as a node, nd in short. The first element will be the data, and the second element will be a pointer to the same data structure. So let's call it as next. So this will be, there are two parts here now. So we have the first part being the data. So that is this. Second point is the pointer to the next element in the list. Now, every time I want to create a new element of this type, I have to write this whole thing struct new struct nd. Instead of that, I'm going to use the type def, and I'm going to rename this struct nd as node. So from now onwards, I will use the node rather than I'm going to use this node rather than this lengthy struct nd to represent this data structure. So let's go ahead and let's start with the first part. And we are already familiar, we need two things over here. One is whenever we think of using the queue, we need two pointers. One is the front pointer, and the other one is the rear pointer. So let's go ahead and let's create these two pointers. Both of them are of type node. By the way, what is this node? Node is the short name for this struct nd. So struct nd is now referred as node. I'm going to call the front pointer as fp and the rear pointer as rp. Okay. Initially, when there is nothing is there, so both when there is no queue is there, both this front and the rear will be pointing to null because there will be nothing will be there. So it is just a blank queue, and that is the indication that the queue is empty. So I'm going to say the front is null. So this is the initial value, and the rear pointer is also null. This is the initial value for both front and the rear pointer. let us first try to insert an element into the node. In order to insert the element, let's write the function called insert. And you know very well the data that we are trying to store is a integer number. So this is our data. So let's give that to the function. So I'm going to say int data as my thing. You can say int n rather than, because we are writing for the examination. So this is going to be, I will not write n because n I'm going to use that variable. Let me use the word data itself. Okay. So I'm going to supply the data there. So first thing that we are going to do is we are going to create a node, and then we will place this data inside this node here. So I'm going to call a pointer to this thing, and we call it as n. That is why I removed this word n from here, because I will be using that n for the node, because n will be used many times rather than this one. Okay, so let's go ahead and let's do the first part. First of all, I have to get the memory allocation. For that, I'm going to use the malloc function. So I'm going to use the malloc, and I'm going to say malloc the size of the node. So what I'm asking with the operating system is that I want a memory allocation that is large enough to accommodate this data structure. So that is the int data and that. So I want this memory allocation. And we know very well that generally whenever we talk about the malloc returns a void pointer. I'm going to typecast that one as node pointer so that there will be a compatibility. So this is done. Let us, so what I got now is, if this part is successful, what I got is a data structure or a structure that has the data and that has the next pointer. So let's initialize this one. So n dot, and I'm going to say data is equal to the data that is being supplied. So whatever data that is supplied to the program will be stored in this n dot data. And because this is a new pointer, so the next pointer, so I have not put a semicolon here, so I forgot to put a semicolon here, so I'm putting that as semicolon. N dot next, that what I have here, I'm going to make it as null. So what I have here now is I have a structure here with the, let's say that value given was say 40 was the value. This data, suppose say if this data is 40, you've got that 40 here in this structure, and we have the next pointer that is pointing to null, because there is nothing is there. So this is what we have done. Now let's look at the initial story. So what we have here is just let's assume that the value is 40 here. Just so we have created this one. Now initially both the, if both the rear and front is null, that means this pointer is this queue is empty because both front and rear are null. So what we will do is, because there is only one element, this will be the front and this will be the rear. Both of them will point to the same structure. So if the queue is empty, how do you say the queue is empty? If both front and rear are null, that means the queue is empty, and we are making both of them point to the first element. So let's consider that situation. So I'm going to go over here and I'm going to say if, okay, so the front pointer, because we are trying to insert, you can go front and rear also, because if the front pointer is null, so what are we going to do? If the front pointer is null, both the front pointer and the rear pointer is equal to the new node. Okay. Why did I only selected the front pointer, not the rear pointer? See, generally when let's suppose I'm going to just bring it here. Okay, I'm going to just make it as 20 just to avoid confusion. So then let's make it as say 30, some value. Okay. So generally, when not generally, when we talk about the queue, we are deleting the elements from the queue from the front side. So we delete the element from the front side. So as we start deleting, the front pointer will go and move to the next pointer, next pointer, and finally it becomes null. When the front pointer becomes null, that means we lost all the nodes in the queue and the queue is empty. So there is a chance that the front will become null two times. For the first time, when there is no elements are there in the queue, that means you have created a fresh queue. Front will be forget about the rear, front will be null. Next case when the front will be null is there is a queue and you keep on deleting one element from the queue. As you keep on deleting one element from the queue, the front will start moving to the next, and finally the front will become null. So if this front is null, that means the queue is empty. We are going to make this front and rear point to the new structure that we have created. Suppose if you have created this new structure and if this front was null, suppose if the front is null, front and rear is null, we will make this front and rear point to the same element because there is only one element. Isn't that these are not these were not there in the list, these were not there in the list. You have only one element in the list, I mean in the queue, and both front and rear will point to the same element. So how do I write that thing is I have already written it here. Let me just press few enter to make it come up. So both front and rear will be pointing to the new element. Now the next question is what if the front is not null? So when does this situation comes? Now look at this scenario. Now the front is not null. Suppose if you create a new, let's assume that this is the new node that you have created. Just ignore this pattern. So just ignore these two. Okay. So suppose if you have created a new node now, so new fresh node. Now this node, because front is not null, what we are supposed to do is we have to make it go to the next element. Remember, because there is only one element, the next of this structure, the next node of this structure will be pointing to null. You know very well the end of the linked list will be grounded, or the end pointer will point to the null, indicating that is the end of the list. Now this list is a very contains only one item, so this is only 20 is there. So the naturally the next pointer will point to the null. Now suppose if I place this 40 here, what will happen? How can I make this 40 point to the next one? First of all, the next pointer of this 20 node was null. First of all, I have to make this next pointer point to this new node, and naturally this is null because we already know that whenever we create a new node, just look at this one. Whenever we create a new node, what we do is we create a new node. Let's say we create a new node. Whatever the data that is given, that we are adding to the data section. So like 40 we add, and the next pointer, this next pointer which is here, this next pointer is grounded, or you make it as null. Okay, so this is the idea. Okay, so there will be a data and the next pointer of any new node that you are creating, that will be null. So the next pointer will be null. So here, this, if you are creating a new node here, the next pointer of this will be null. So that is because any new node that you are creating, there will be a data and the next pointer will be null. So that is what is done. Now what we are supposed to do is we have to attach this to the queue. How do I do that? So I know that both front and rear is pointing to the same element because there is only one element in that. So I'll take this rear is pointing to this node. I will take the rear, and the next rear is pointing to this node. The next of it is null. I will make it point to this. So next of this node, which was null, is made to point to this one. Okay, how can I do that? Because rear is pointing to this. So rear dot next, because rear is pointing to this one, rear dot next, this is rear dot next is null, but I am changing it and I am making it point to the next element. So how can I do that thing? Let's go to the code and let's do that thing. So I'm going to say, can I say a rear pointer, rear dot next is equal to the new node that I have just created. The new node that I have just created. So this is the new node. I am just making rear dot next. So rear pointer. So this is let's say this is the rear pointer. Rear dot next is made to point to the new node. That is not the end of it. So what I have done is I took this rear and I made it point to the next node. But you know that in a queue, the front will always point to the beginning of the node, rear will point to the next element of the queue. Now the scenario is, this is the scenario. Let's go here and let me get it here. So this is the scenario. So I have made this 20 point to the next node. But what is the problem? In this case, front is pointing to the beginning of the node. This is true in Q. In Q, the front pointer will point to the first element, but the rear must point to the next one. So rear is not supposed to point here. Now I have to move this rear and make it point to the next element. So if I add one more element, suppose if I add one more element, then I have to make this rear point to the last element. How can I make rear point to the last element? New value of rear is old value of rear, that is rear is pointing here. So rear is pointing to this node. This dot next, it is pointing to the next element. This dot next, rear next is pointing to this location. So the new location of rear is the old value, old node where the rear was pointing, and then take its next pointer, point it to the next node, and make this rear move from this next to the next node. So make this rear make point to the next, or move it to the next one. So how do I do that thing? So I'm going to say, so what I can say is, where is it gone? So I'm going to say a rear pointer is equal to rear pointer dot next. Okay, now I want both of them are part of the else statement. So I'm going to put this one, select both of them, hold and drag it inside, and they will be there. And if you want to format it, right click and you have the format use style, and it will format it beautifully for you. Okay, so both of them must be part of the else statement. So I put them inside the flower bracket. So both of them must happen together. So what is that you are doing? First of all, if you want to get a new from the rear, I will say from the rear I will make it point to the next node. Okay, and then move this pointer to point to the next node. So the rear, first I will make this null point to here, and then make this rear point to this element. So that rear will be always pointing to the last element of the queue. So this is for, let's go here, this is for the insertion. So suppose if you come up to this point without any problem, then I'm going to say print f, okay, and slash n element inserted. Okay, so then the element inserted. Remember, we are not checking whether the queue is full or not, because it is a linked list structure, and we can keep on adding it. Now let's try to delete one element from the queue. How can I delete one element? Let's say this is your queue now. The last element is grounded. So the first thing I have already told you, if the front itself is null. So what is the meaning of saying when the front will be null? When the queue itself is empty. If the front is null, then there is nothing to be deleted. Queue itself is empty. So let's take care of that. I'm going to write one function here. let's say void, and I'm going to say delete. And let's start with the first one. If this front pointer itself is null, that means this queue is perfectly empty, then we are going to say print f, and we are going to say /n, and we are going to say queue is empty. Okay, and let me say /n. I'm going to put the /n here also. This /n, I'm doing it so that it looks beautiful in the output. That's the reason. Okay, else part, that means to say that else there are few things that you can do with the queue. Let me put the sign so that it comes up. Okay, so else, so what has to be done? So the two things you must do here is suppose if the front pointer is pointing here. Okay, front pointer is pointing here. So somehow move this front pointer and make it point to this one, okay, so that this is freed. So make this front pointer point to the next element. So that is the thing. And then you have to free it. Remember, in order to free this one, if you just move this front pointer here, suppose if you make this front pointer, let's say I'm going to remove this. If you make this front pointer here, this link is lost. You cannot free it. First of all, before moving this front pointer, make a temporary link to this one. So make a temporary pointer here so that you can get a grip on it. Suppose if you simply move this front pointer on to the next one, then you cannot come back and get this node. This node is lost altogether. So there is no way you can come. They say you can go front. You can go front, but you cannot come back. Once the front goes here, you have lost the handle for that particular node, then you can free it. So before we move this front, to make a temporary pointer and point to this so that you can still get the handle on this particular node, and then finally remove it from the memory. So I'm going to create a temporary node. You can call it as temp, but because you are writing during the examination, I will call it as T for temp. So T will be pointing to the same location as that of front. So I'm going to create in other words, I'm going to create a temporary pointer T, and it will point to the same pointer that the front is pointing. Suppose if the front is pointing here, then this T will point to the same node. So wherever the front is pointing, the T will point to the same node. So that is what I'm doing it. Now, so why did I do that? So that I can get a grip on it. See, remember the minute the front goes here, there is no way you can come back and free this from the memory because you lost the link. Okay, so you need to have a hold on that particular link. So you must have a handle for that particular node. Now, how do I move this front to the next one? How to move this front to the next one? Now, I know that this node dot next will point to the next node. So front is pointing here. So front dot next will point here. So I'm going to say front is pointing here. Front is pointing here. Front dot next will point to the next node. So I'm going to take that and make the front point here. So front dot next will point to the next node, and I will make the front point to that location. How do I do that thing? So front is equal to new value of front is equal to old value where the front was pointing and the next pointer. Okay, so new value of a front is old value where the front was pointing, but not the just old value. That value's next. That value's next is this. That value's next is next pointer. So for new value of front is this next of that. Okay, so that is what you got. Okay, So you got that. That is not the end of it. Before I delete, I'm going to just use the printf statement to say that this is being deleted. So I'm going to say, let's say /n, and I'm going to say %d is deleted. Okay, what is this? A %d. T is pointing here. Remember, T is pointing, still pointing here. So T dot data. So T dot data is this 20. So I'm going to get that T dot data. T dot data. Okay, so that is this data. Okay, T dot data. So I got that. Why didn't it give me? Okay. So T dot data is the one that I'm using. Let me use one /n again. This /n, so I'm using it to make it output appear properly. And finally, I'm going to free this T from the memory. Remember, so T was pointing. Where is it? T was pointing here. So T was pointing here initially. So look at here. So you have a, let's I'm going to do it here itself. So there is one other node. Okay, one other node. Let it whatever is the value. So T and the front is pointing here. Okay, T and the front is pointing to the same location. Then I make the front point to the next one. So front is pointing now. T is still pointing here. I will take this T and I'm going to free that T from the memory so that it is lost from the memory. Now let's go to the next option. And what is the next option? We have to display the element of the queue. So I'm going to say void display. So how can we display? Again, the first thing is a very simplest one. What is this simplest one? If the front pointer itself is null, that you know very well, when the front pointer is null, the queue is empty. You know, this is one of the simplest one. If the front pointer is null, the queue is empty, and we are going to use that option now. So I'm going to go here. Oops. I'm going to go here and I'm going to say if a front pointer is null, I'm going to use the printf and I'm going to say /n and I'm going to say what you can say is q is and once it told me that it is empty. Okay, /n. Then let's go to the next one, else part. So let's go with the else part. What if there are some element in the queue? So in that case, first, wherever the front is pointing, you print this value, make it point to the next, 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 next. Remember, you cannot move the front itself. First of all, get a temporary pointer that will point to the location of the front. Okay, and make this pointer go to the next, 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 and so on. So every time it is going to the next, 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 you start printing the value. So you first make a pointer that is temporary pointer, let it point to the same location as that of the front. So let me do that particular thing. So I'll create a node pointer, let's say T, so T, and it will point to the front pointer and what it is supposed to do. So this pointer T will point to the this one. First print this value and make it point to the next one. Then print this value, make it point to the next one, print this value, make it point to the next one, print this value, and finally when it reaches the null, you are done with it. Okay, so you go until this pointer becomes a null. So as long as this pointer, so I'm going to say while this temporary pointer is not null, null is in this capital null. Yeah, what you are going to do, you start printing the value. So let's let me first put this one statement here. This is again to make the things beautiful. Let me say /n elements in the queue. Elements in the, you say, in queue. I don't know. The is there or not? Element in queue. Okay, so this is so that the person knows this is just to make the output beautiful. That's it. Okay. So first of all, let's come back to the same story. So first you print the value. So t is pointing to the same location. T is pointing to the same location. First print the value. First thing we'll do that thing. First let's print the value. So I'm going to say percentage d, and I will put one space there, percentage d, and one space there, and then I'm going to put t dot data. So it will point, it will get the data. So t is pointing here. So t is pointing here. T dot data. You got the 20. Then t dot next. Move this t to the next value. New value of t is a old value of t dot next. Wherever the next is pointing. So new value of t is a old value of t, and then point to the next one. So let's do that thing. So new value of t is old value of t, and wherever the t is pointing, next. So you do this thing, you continuously do this thing until t becomes a null. So what you're doing is you first print this 20, then the new value of t is old value of t plus a new, so t will be pointing here. Again print the value of 40. Again new value of t is old value of t, pointer next, so t will be pointing here. Print the value 30. Again new value of t is old value of t plus this next pointer, so t will be pointing here. Print this value. New value of t is old value of t plus dot next is null. So the minute t becomes null, you know that this while loop will break, and then you are coming out of it. Now let's write the main program here. So I'm going to write void, what is happening, void main. Okay, let's start doing it. Before I do it, let's sometime what happens is these pointers, they actually, this flower brackets, actually they misplace. Okay, done. I think I've not done that. So let's start with the first one. We need the data. Okay, and there are few things that you can do. What are the things that you can do? You can add. What are the things you can insert? You can delete, you can display, and you can exit. Okay, so the choice 3 will be, choice 4 will be, first one is choice 1 will be to insert, choice so choice 1 will be to insert, choice 2 will be to delete, choice 3 will be to display, and choice 4 will be for exit. So ch will be the choice that the user will be giving. So I'm going to use the do while loop. So do while the choice is not equal to 4, because I know that the choice 4 is null, is exit. So let's start with the menu here. So I'm going to use this printf, and I will start with the /n. Choice 1 will be insert, /n. Choice 2 will be delete, /n. Choice 3 will be what to do, display. Okay. /n. Choice 4 is exit. So this is it. And /n, I'm going to put dash 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 dash, start from the dash here. So dash 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 few dash, and /n your choice. Okay. And I'm going to put one colon and some space here so that it looks neat. Okay. Then I'm going to ask the user what is your choice. So how can I ask? Percentage d, and /ch. Done. Okay, let's switch on the value of this ch. So few cases are there. So let's start with the one case at a time. So we'll start with the case one, number one. So case one, you know very well, case one is for insertion. To insert, we need the data. So I'm going to say printf, and I'm going to say enter a number. Okay, I will put /n here so that do I need a /n? Okay, let it be /n now, because not sure. Okay, let's again, that /n is to make the output beautiful. That's it. Not otherwise. Okay, slash d again. Why this percentage? That I think that key is down. And I'm going to read the data. So this is the data. You have the data here. So I'm reading that data. So you got the data. Let's go and let's insert it. So I'm going to say insert the data. So done. And then we are going to take a break. Let's go with the case number 2. What is the case number 2? Case number 2 is to delete. So I'm going to say delete and done. Let's take a break after that. And the case number 3 is to display. What is the spelling I used here? Display. Okay, so display, display. Done. And let's take a break. Case number 4 is what is the case number 4 is to exit. So we're going to say printf /n exiting and put a dash 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 and /n, so that we are exiting. Then let's put a break here, and the default is printf. Okay, again it came as printf, and let's use this /n wrong choice /n. Let's put this one, and okay, let me remove all the unnecessary space. That's the extra lines which were there. Hopefully everything is proper. Let me save everything and then give it a try, see whether there is any error. So if you find that you have clicked and nothing is happening, and then you have to go to this view and then go to the logs, and you will find that there is a problem. So just go to the view and find the log, and you have somewhere you have put to print. Okay, so let me say search for that. Where is that print? So one print is here. Hopefully that was the case. Let me try one more time. Okay, done. So let me insert the value 10. Okay, value inserted. Let me display it. So let me display it. Okay, element in the queue is 10. Okay. Let's go one more, insert 20. Let me display it. Element in the queue is 10 and 20. Let me insert one more element, 30. So element in the queue, I'm pressing 3 for my choice. Okay, let me delete the element. So I'm going to delete 2. So 10 is deleted, you know very well. This is the, where is the pointer? So this is the queue here. Okay, first element is 10. That 10 got deleted. Okay, so what is remaining in the queue? Let me type thing. What is remaining in the queue is 20 and 30. Now if I pull out one, so this will be deleted. So let me pull out one, delete, and let's show 3, and only one element is there in the queue. So let me delete this one also. 30 is deleted. So now if I display the queue, now I must, the queue is empty. If I try to delete an element, it must say the queue is empty again. So the choice 2 is also same thing. So try to delete and you say the queue is empty. Let me try to insert one element after all the deletion. Let me insert one element. So let me insert and let me say insert 50, and the element is inserted. You notice the element is inserted, and let me just to display that element 3, and only one element is there. If I insert one more element 60, and if I do it, and you know that the queue will still continue from that point onwards, and I can anytime delete it. So if I delete and then display it, 50 is gone. Okay, so 50 is deleted, and so on. So you can do that. I'm going to press 4 for exiting. If any other choice is there, the choice number 5 which is not there, I get the wrong choice, and finally I put the right choice, exit. Okay, that's all in this video. Thank you for your interest. We will meet again in the next exercise.